Okay, so let's talk about enzyme kinetics. So enzyme kinetics talks about the rate of enzyme catalysis. So remember, enzyme catalysis is when we are catalyzing chemical reactions using an enzyme, which remember, an enzyme is just a protein that has catalytic activity. So enzyme catalysis depends on three things. It depends on the concentration of the substrate, which we're going to represent like this. Remember, anytime we have brackets like that, that represents concentration in molarity. It also depends on the concentration of the enzyme. The third thing that enzyme catalysis depends on is something called the rate constant. And the rate constant is something called Kcat over Km. And these are both terms that we have not identified or defined yet. So let's take a look at those. So I'm going to define those, and then we're going to look at some graphs that are going to explain this in a little more detail. So let's look at Kcat first. So Kcat, Cat stands for catalysis. Kcat is called the turnover number. So the turnover number tells us how many substrate molecules are converted to product by one active site per unit time, which is usually seconds. So that's the Kcat, the turnover number. So remember, in biochemistry and sometimes biology, we talked about the reactant as being called the substrate. So this is the starting material, and we still call the end result the product. So remember, in chemistry, you're used to something like this. And in biochemistry, you're going to see it written like this. So just a little more information. We call the reactant a substrate. The enzyme that catalyzes this reaction is oftentimes written over the arrow, not always, but often you'll see the name of the enzyme over the arrow and then the product. And most of the time, the name of the enzyme is named for the substrate that it is catalyzing. Okay, so that's just a little review. So Kcat is the turnover number. It tells us how many substrate molecules are converted to product by one active site per unit time. The Km describes the attraction of the substrate to the enzyme. Remember, there are interactions between the substrate and the enzyme, the active site of the enzyme where the substrate binds. There's all those interactions between the non-covalent interactions between the R groups of the substrate and the enzyme. Okay, so the way that we describe this, there's two graphs that you are going to need to be comfortable with. One is called the Michaelis-Menten graph, and one is called the Lineweaver-Burk plot. The Lineweaver-Burk plot is a double reciprocal of the Michaelis-Menten plot, so let's start with that first. So the Michaelis-Menten graph, it plots the reaction velocity, which sometimes we call the V naught, from 0 to 100 against the substrate concentration. And this maxes out at 100% reaction velocity. We would call this the V max, the maximum velocity of this reaction, of this enzyme. So this is specific to every enzyme. Every enzyme has its own V max. So the graph is always going to look something like this. Something like that. So what this tells us, the important thing here is this graph can tell us the value of the Km. So the value of the Km, which we said describes the attraction of the substrate to the enzyme, we said the Km tells us how attracted the substrate is to the enzyme. What it is it is the substrate concentration at 50% of the reaction velocity. So if this is 100, we'll say this is 50. So we go over here, we see where these intersect. This substrate concentration right here, this is the Km. The Km is a substrate concentration. The Km is the substrate concentration at 1/2 the Vmax. That's the definition of the Km. And this Km describes the attraction of the substrate to the enzyme. So let's see what this means if this Km is a big number or if this Km is a small number. If the Km is high, meaning down here more, that means this attraction would be lower. If the Km is high, that means the enzyme has a lower affinity for substrate. If the Km is low, like if the Km was back here, that means this curve would be really high to have 1/2 the Vmax. A low Km means the enzyme has a high affinity for the substrate. So this is the Michaelis-Menten plot. Also from this, we can calculate the velocity, the reaction velocity. I'm going to go ahead and write that up here. The reaction velocity, V naught, reaction velocity, equals the Vmax times the substrate concentration over the Km plus the substrate concentration. So that's how we can calculate the reaction velocity at different concentrations, or if we know the reaction velocity and the substrate concentrations in the Km, we can calculate the Vmax. This is a relationship that we're able to calculate based on this relationship. Okay. So another relationship that we're going to look at is something called the Lineweaver-Burk relationship. The Lineweaver-Burk relationship is a double reciprocal, so it's 1 over the reaction velocity and 1 over the substrate concentration. We're going to use the Lineweaver-Burk plot when we look at enzyme inhibition, which will be coming up next.